this video, on the worksheet, I'm sorry. So what information can we get from a Punnett square? It can give us a genotype, that is what alleles are present, expressed or not. It will help us determine the phenotype, which is the physical trait that is expressed. It gives us a ratio of homozygous and heterozygous. Remember, homozygous the same, heterozygous is different. Let's do a quick review. What does a Punnett square use? Alleles or genotypes. What is a genotype? It's alleles expressed or not expressed. What is a phenotype? The physical trait that is expressed. What is homozygous? It's the same allele. What is heterozygous? It's different alleles. How is a dominant trait represented? With a capital letter. How is a recessive trait represented? With a lowercase letter. So how do alleles determine our traits? We've been talking so far about complete dominance. Now we're going to go into what is incomplete dominance, codominance, epistasis, and sex-linked traits. So complete dominance is what we've been talking about. That's when the heterozygous phenotype is indistinguishable from the homozygous parent. That means if you got the dominant trait, you don't know if you are a homozygous dominant or a heterozygous dominant. So if you have the dominant trait, it is expressed. That is what complete or simple dominance is. Incomplete dominance is when the heterozygote displays a phenotype that is intermediate between the phenotypes of both homozygous parents, one of which is homozygous dominant and the other is homozygous recessive. Although the offspring may show a variety of phenotypes, each one will lie along a continuum bracketed by the homozygous parental phenotypes. What does that mean? That means that you get a blend. So, for example, we have a red flower parent and a white flower parent, and they're both fully dominant. But when they are crossed, we get a variety of pink shaded phenotypes. So we get a blend. So now we're going to set up an incomplete dominance Punnett square. Make sure you include a key, what your cross is, and the geno and phenotype ratios. So this first one is a pink flower plant with a red flower plant, where red and white traits show incomplete dominance to pink. So when we're doing incomplete dominance, we are going to use two different letters. So red and white. So two uppercase R's would represent a red flower, two uppercase W's would represent a white flower, and an uppercase R and an uppercase W would represent the pink flower. So we're going to set up our cross. We have a pink flower crossing with a red flower. So we know that red is our two R's and pink is our W. We're going to set up our Punnett square. Now we need to determine our genotypic ratio and our phenotypic ratio. Now, in incomplete dominance, the genotype and the phenotype are usually the same. Oh. So we have red, 2 of them, and pink, 2 of them. So our genotypic ratio is 1:1 or 2:1. What is expressed? We have 2 red flowers and 2 pink flowers. Or a 1:1 ratio. So if we crossed a red flower with a white flower, we would have a 50% chance of having a red flower and a 50% chance of having a pink flower. I would like you to stop this video at this point and do question number 5 on your own. So the next kind of dominance we're going to talk about is codominance. This occurs when the phenotypes of both parents are simultaneously expressed in the same offspring. Codominance is a specific term for a system in which an allele from each homozygote parent combines in the offspring, and the offspring simultaneously demonstrate both phenotypes. A good example of codominance is A-B-O blood groups. So an A type A blood is codominant and type B blood is codominant. So if an A parent and a B parent have an offspring and they have an A-B offspring, both the A and the B alleles will be expressed. Another example of codominance are roan horses, which is red and white, just like the flower we talked about, except in horses. And if you go and actually look at all of the hairs on the horses, you will see a mix of the red and the white hairs being expressed. So what's the difference between codominance and incomplete dominance? So codominance, like we said, is when both traits are expressed. So this flower, if it was codominant between the red and the white flower, both the red and the white would be expressed. If it's incomplete dominance, it would be a blend, which is when you get the pink flower. So now we're going to practice doing a Punnett square with codominance. Just like incomplete dominance, you want to use different letters for each trait so that you can show that they are both dominant. So we're going to cross a red horse with a white horse, where red and white are codominant to produce a roan horse. First, we're going to start with our key. I'm going to represent the red horse with 2 uppercase R's and the white horse with 2 uppercase W's. We're going to put in our cross. We're going to build our Punnett square. And then we need to figure out our genotype ratio and our phenotype ratio. Just like incomplete dominance, most of the time, the genotype and the phenotype are the same. So, what is the genotype that shows up in our Punnett square? We have the roan, which is the red and white showing in all 4 of them. So we have a 100% chance of having a horse that would express both the red and the white color. Same thing goes for the blood type or the phenotype. So I'm going to help you set up the next example because blood type is a little bit different. For a key, I would like you to use this for your key. A and B are both dominant, but O type blood is a recessive trait. So I'm going to set up the key and the cross, and I'm going to expect you to try to do the Punnett square, the genotype, and the phenotype on your own. So the cross would be, we're going to do a heterozygous A type person with a heterozygous type B, which means they're different. Because O is the recessive trait and it's heterozygous, it's a dominant A and a recessive O, a dominant B with a recessive O. I would like you to try to set up your Punnett square and do your genotype and phenotype ratios. That's what we're going to cover for today. I will go over sex-linked traits and pedigree charts with you next class. Please return the packet so that I can check it over, look at it, see what questions I need to ask you when we come back. If you have any questions, you're welcome to ask them when I come back. I'm not going to grade these right now. I just want to see where you are. So please complete questions 1 through 7 and turn in the packet.